5.1, crude oils, fuel and organic chemistry. So the first question says, it shows you some reactions that would take place with an alkane, and then there's some reactions that might occur. Complete the diagram by giving the missing structure. So the missing structure, that add in bromine. Bromine water is going to react over the double bond of that alkene there. So you get rid of the double bond and instead you add 2 bromines. Describe what we've seen during this reaction between the ethene and the orange bromine water. They've given you a little bit of a hint there because they've told you that it's orange bromine water. It will turn colourless, okay? If it was an alkane, which is seen forming from the reaction A, nothing would happen. It would remain orange. Give the names of the types of reactions labelled in A and B. So reaction A is an addition reaction. Reaction B is polymerization, which is forming a plastic. Moving on then to question 2. The table below shows the names of some molecular formula and the structural formula of the first 2 members of the alkene series. So alkene double bonds. Complete the table by giving the structural formula of butene. Okay, so you've just got to draw it out. You need to make sure you've got the double bond. The double bond could be moved slightly 1 over. But that is what it would look like. Count how many carbons you've got. So 1, 2, 3, 4. Count how many hydrogens. You've got to have 8 hydrogens. Okay, each carbon can only have 4 bonds. Explain how polypropene is formed from propene. That is again making a plastic to undergo polymerization. So the double bonds of propene open. So you get rid of the double bonds. Propene molecules join together to form repeating units. This requires high temperature, pressure and a catalyst. Remember the reactions, okay, the reactants that you need, the conditions that you need. Okay, as you can see, that question was 4 marks. Not a hard 4 marks. You would have lost 2 marks if you hadn't have said high temperature, pressure and catalyst required. Moving on now to question number 3. The table contains some common alkanes and alkenes. Fill in the missing information. So fill in the missing information. So the bottom part is most probably a little bit easier because the first bit, all you've got to do is count the number of carbons, and you have got 4 carbons. 4 carbons, and then you have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. I've made a mistake there, sorry. So that should be C4H10, and that is butane. Then moving up, then you've got propene, so you know you've got a double bond. Double bond, then you should remember eth, prop, so it's got 3 carbons, and then try and work out then the hydrogens based on how many carbons bonds you have got. Moving on then to question number 4. This question comes up quite a lot. Make sure you remember because there's some keywords you've got to include or you don't get the marks. Crude oil is a mixture of hydrocarbons. State how it is formed for 2 marks. The remains of marine organisms which die over time and fall to the bottom of the seabed, which are subject to intense pressure, so stuff fall on top of them, over millions of years, okay? You cannot write thousands of years, you cannot write hundreds of years. It has got to be millions of years, and it's got to be marine organisms as well, okay? Describe, then moving on, you've got a nice table filled with different things that would be collected from a fractional distillation. Describe how 3 properties of crude oil fractions depend on the size of the molecule. So you are just reading off the table what you can see different. So as the molecule size increases, so that's the second column, the number of carbon atoms, so the bottom one there, diesel has got 15 carbon atoms compared to fuel gas, which only got 1. As the molecule size increases, so does the boiling point, so they get higher temperatures required to boil them. The darkness of the colour, so they go from like a pale yellow colourless all the way down to a brown colour. Viscosity, which means how runny they are, so they start off quite runny and they end up quite solid, and how easy it is to burn. So the bottom ones are really hard to burn, again, compared to the top ones, which are quite easy to burn. That is a really nice question for 3 marks because you are just taking information from the table and putting it in your answers. Moving on then to question number 5. State what is meant by hydrocarbon. Again, 1 mark, an easy mark, but you've got to just remember it. A molecule which contains only hydrogen and carbon atoms. Then you're looking at a fractional distillation. They've just given you like a brief overview of what a fractional distillation looks like. So you've got crude oil going in and then the different molecules that you make based on how well it boils. So it says state why fractions are not single compounds. So you can see that things come out maybe on each fraction that are loads of different things. Okay, each fraction is set at a certain boiling point. So each of these, fuel oil, diesel, kerosene, they've got a certain boiling point where they come out. Several compounds will have the same boiling point. So a couple of things will end up coming out in the kerosene one, not just kerosene, a couple of compounds will end up coming out. Moving on then to the second part of this question. Most fractions are used as fuel. However, some are converted into small reaction molecules that can be used to form plastics. Okay, name the process that is used to produce the small relative molecules. So you produce normally from a large chain alkane, you break it down into a smaller alkane, which is more useful to you, and an alkene. This is called cracking, and then they have to undergo polymerization to make plastics, which breaks the double bond so they can form polymers over and over again. So that's the answers to I and II. Question or part D, ethene is an example of a monomer which is used to produce polyethene. The structure of ethene is shown below. Describe what happens to ethene molecules to produce polyethene. Like I was talking about in the polymerization, that double bond has to break, okay? It turns into a single bond, which allows it to form bonds over and over again to create a long chain polymer, which is then used in plastics. Give one disadvantage of the use of plastics such as polyethylene. They aren't biodegradable, which means they either produce an awful lot of carbon dioxide when burnt or they fill up landfills, okay? Again, you could in that question talk about them getting into the sea, stuff like the turtles and the bird, okay? There's an awful lot of questions that you can use there. Moving on then to question 6, which was a little bit of a harder question. The following diagram shows an experiment that could be carried out in the laboratory to obtain ethene from dectane. Okay, so you're heating up the dectane, you are cracking it to produce ethene, but you also produce another molecule then, which will be an alkane. So you produce an alkane and an alkene. Mineral wool soaked in dectane, and then you add some heat, some broken china is added in as well, and then you heat it up and then you produce ethene. Complete the following symbol equation for the reaction taking place. Nice, easy 1 mark. All you've got to do, you ended up with 2 carbons and 4 hydrogens. You started with 10 carbons and 22 hydrogens. So it's simply just working out the difference. So you've got 8 carbons and 18 hydrogens. Name the process. That is cracking, breaking down a long chain alkane into a smaller chain alkane and an alkene. So the alkene is the C2H4, and then the alkane is the H18. Moving on to the second part of this question. Ethene is a hydrocarbon. The following diagram represents the apparatus that can be used to investigate the products when ethene is formed. Okay, state what would happen to the lime water in test tube B and give a reason for your answer. I actually wrote this in the wrong box, unfortunately. So lime water will turn cloudy as CO2 is present. So as soon as you see a lime water question, the likelihood is they're going to ask you about what it does in terms of being present with carbon dioxide. Okay, then the answer in the green is the answer to II part I. State what would happen seen in the test tube A and give a reason for your answer. Liquid forms when the hydrogen is burnt. State II then, stay and explain what would be seen in test tube B. No change as carbon dioxide is not present as there's no carbon left. Okay, moving on then to question number 7. There are quite a lot of different types of questions that can be asked in terms of this topic. Name the family to which each of the following pairs of compounds belongs to. Okay, so you're looking at A and C. A and C have got no double bonds. They've also just got carbon and hydrogen. So straight away I know they're alkanes. Okay. Question then the second part. E and F, they've got a double bond, but they've only got they have only got carbon and hydrogen, which makes them alkenes. Describe the chemical test that would be carried out to distinguish between the compounds C and E and give the expected results for both. Okay, so that's 2 marks. The first bit, and you can see I've highlighted, what is the chemical test? It is to add orange bromine water. With C, because it hasn't got a double bond, you will see no change. It will remain orange. With E, it will react over the double bond, essentially forming a halogen or alkane, and it will turn from orange to colourless because the double bond is going to have a reaction. Part C of this question then is asking you about isomers. Give the meaning of the term isomer. Isomer means same molecular formula, different structural formula. Learn that off by heart, recite it to yourself. Draw in the space below the structure of the isomer C4H10. Okay, so you can see that you've got a methyl group coming off there. That's the methyl. That's the methyl group there. Okay, so it would have the same, it's got the same amount as carbons if you draw it as a straight chain, but it's got a branched section to it instead. Give the letter A to F of the one other compound which has an isomer. Draw the structure of this isomer. So if you flip back on the other page, the other one that could form an isomer, you're looking at things that tend to be a little bit of longer chain, and that would be compound D. And that one is because the original structure you're shown is like a bent structure. This one is a straight chained isomer. Okay. Question number 8 would be a lovely 6-mark question if it was to come up. It's on the fire triangle. Firefighters use their understanding of the fire triangle to put out fires. Every year, thousands of acres and more land are destroyed by fire. Firefighters use several different methods to put out this type of fire. Thinking about the fire triangle then, you've got oxygen, you've got fuel, and you've got heat. Okay, so as soon as you eliminate one of them, as soon as you get rid of one of them, that means that the fire should hopefully go out. Okay, so suggest 3 different methods. You see I've highlighted that, and each method was referred to a certain part of the fire triangle. So I've drawn the fire triangle there. State how each method is effective. Okay, method number 1 would be to use water. That would remove the heat. Method number 2 would be cover with a fire blanket, which removes the oxygen. And then the final part, method number 3, would be to make a fire break or to start deforestation at some point, and that would remove the fuel. Moving on then to what I believe to be the final question. Question number 9. The diagram shows the representation of crude oil, so it's a fractional distillation question. It's a fractional distillation question. And as you can see, it says write an account of this industrial process. So what's happening in this process? Again, I've highlighted all the keywords, and then you've got 3 bullet points that you need to include. Name of this method of separation, what crude oil, and then description of how crude oil is separated. So make sure, if I've set it out in bullet points, you could set it out in paragraphs. The first thing I've done is answer method of separation is called fractional distillation. I've come up with 6 bullet points because it's a 6-mark question. Then I've described what crude oil is. Crude oil is a mixture of hydrocarbons. If you wanted to go one step further there, you could have described how crude oil is formed. So marine organisms fall to the bottom of the sea. Intense heat and pressure formed over millions of years. Then moving on to description of how crude oil is separated. Smaller hydrocarbons will rise higher up because they're lighter after boiling, and they will condense higher up. So they're more likely to condense at the petroleum gases petrol section because they are lighter, they are smaller hydrocarbon change. Larger molecules will have higher boiling points, okay? So that means they're going to separate lower down. Hydrocarbons with similar boiling points condense at the same level and column. Like we talked about before, you might have 3 or 4 compounds coming out of the same section. That is just because they have similar boiling points. That would have got you 6 marks as long as you'd written it with correct English and sentences and in like a good organisation.